So the next logical step after Newton's third law is to step into momentum. Newton's third law really shows, or is really part of momentum. So what is momentum? You've probably heard of it before. Maybe a baseball team is gaining momentum. They're scoring lots of runs and they're really going. Or, I don't know. You can probably think of something else. But anyway, as far as momentum goes, we need to define it. What is it? Well, here we're actually going to go back to Newton's second law. Okay, so Newton's second law, as you remember, said that F equals ma, or force equals mass times acceleration, which really came from the idea that the acceleration of an object is equal to the force divided by the mass. So however hard you push on it, divided by the mass of the object, that's how much it accelerates. So you can also look at it as the force needed to push on something equals whatever the mass you're pushing with or pushing on, and how much you're accelerating it. Now, if we redefine that, if you remember, acceleration, how much something accelerates, is also how much the velocity changes over a certain period of time. So, what we can do is we can replace A, we got to keep the M in there, okay? But change A to delta V over T. And that's the same thing as doing, here we go, M delta V over T. Now, in other words, he's saying that the force that you apply onto something, okay, is equal to how much this quantity here changes. In fact, I'll even make another color to add emphasis. How much this quantity changes. This mass times the change in velocity, or really, you can call it the change in mass and velocity, okay? But mass times velocity, what is mass times velocity? That, my friends, is momentum. So in other words, he's saying that the force that you apply to something is directly proportional to the amount of momentum that you give it. How much its velocity changes, which is also dependent on the mass and how long you apply it for. So anyway, let's move on. So what is it defined as? Well, it's defined as the product of an object's mass and velocity. So if you remember, then mass is m, velocity is v. And if you remember, mass is measured in kilograms and velocity is measured in meters per second. Okay. I like to think of it as the oomph that something has. Okay, it's kind of like saying this is momentum is how much oomph it has. If it has more oomph, that means it takes longer to stop it. Okay, like a bowling ball has more oomph than a tennis ball coming at me at the same speed because the bowling ball has more mass. Okay, same thing. A bowling ball rolling very, very slowly has much less oomph than a bowling ball moving really, 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 really fast because it has more velocity. Okay. And that's where we get the equation for mv. Now, somebody also said it's inertia in motion. I find this a little confusing, but I think it's worth noting because inertia is an object's resistance to changes in motion. And so and remember, that was just based on mass. Inertia is directly proportional to mass. So then if inertia is proportional, I believe that's the fishy, proportional to mass, then momentum would basically be the same thing. Remember, it's mass and velocity. It would be directly proportional to what we call inertia in motion. Okay? All right. So that might be a little confusing, but focus on this. The product of an object's mass and velocity. That's the key. All right? So we find it by the following. Momentum equals mass times velocity. Now, of course, you know that mass is abbreviated with m, velocity is abbreviated with v. Momentum is abbreviated as not m, because mass is already taken, not mo, not mom, because that would just be weird, not anything else. It's really weird. And I remember looking this up. Maybe I'll give somebody extra credit. In fact, I think I will give somebody extra credit if they can come tomorrow with the answer to why do we use the letter P for momentum. Okay. Now, P is mv. P is momentum. That's the deal. I don't know why. You're going to tell me tomorrow because you're going to figure it out. But P equals mv. All right? It's as simple as that. You take the mass times the velocity, and you get the momentum. The faster it goes, the more momentum it has. The more mass it has, the more momentum it has. So it's actually quite simple. If you think about it, it's really quite simple. Now let me show you what we mean by the units. This is the units parts here, okay? Now, the mass, if you remember, is measured in kilograms, okay? That's why we have that right there. And velocity is measured in meters per second squared. So all you're doing is you're taking kilograms and you're multiplying it by meters per second squared. Now mathematically it looks a little weird, okay? It's kind of hard to multiply a whole number times a fraction, so, well, kilograms is the same as kilograms over 1. And so then you just multiply across and you get kilogram times meters over seconds. I know, it's a lot, but hey, you didn't have to deal with the big long abbreviation for Newton, so you can deal with one here, all right? But these are the units for momentum, okay? I would suggest writing those down somewhere where you will remember them, okay? So we have an essential equation here, which means you should be writing this in your essential equation sheet. We have P equals mv. It's actually really that simple. Okay, that's momentum is defined by mass and velocity. Now you can switch that around, remember. You can do a little bit of algebra here, and you can do, let's see, P equals mv. Same relationship, but let's change the flavor. Let's divide it by v on both sides. We'll get rid of that, and we'll get m equals p over v. That's another one you can put over here. M equals p over v. Or the mass of an object, if we know the momentum and its velocity, we can calculate its mass. We can also do something else. We could do, instead, let's do p equals mv, and let's divide it by mass on both sides. And you get, whoop, v equals p over m. So we can calculate an object's velocity if we know its momentum and its mass. So right there, 3 essential equations for you to put on your essential equation sheet. Okay? Go for it. I would suggest doing it now. Okay? All right. Okay, so let's try a couple test problems. Okay? So let's do the first one, momentum problem. Okay, remember we take a deep breath. You can do this. Let's read through it and visualize what's happening. A 5-kilogram bowling ball is rolled down the alley with a speed of 3 meters per second. So 1/1000. It's going pretty fast. Okay. What is its momentum? It's actually pretty easy. Now remember, we underline and list our givens. So we'll do underline 5 kilograms. Now what's 5 kilograms? That's a mass. So we can write mass equals 5 kilograms. It's rolled down the alley with a speed of 3 meters per second. Oh, there we go. There's another given, 3 meters per second. What is meters per second measuring? Well, I told you already, speed. So velocity equals 3 meters per second. We can just use speed and velocity interchangeably here. Okay. So we're asking what is its momentum? That's what we're looking for. So we'll do P equals question mark. All right. So now we're looking for a relationship between the mass and the velocity and how it gets us our P. Now we looked at our essential equation sheet and we found the equation P equals mv. So what do? We write P equals mv. And then we start substituting and solving. Okay. So we've got P equals, let's see, M is 5 kilograms. V, right here, is 3 meters per second. Okay. And remember, we do the numbers in the units separately. So 5 times 3 is 15. And then the units, We could either remember it from when we wrote it down before, or we can just look at the units right here. Kilogram dot meters per second. Okay? So the momentum of this bowling ball is 15 kilogram meters per second. You got to know how to do this, because when we start getting into impulse and conservation of momentum, if you don't know how to calculate this, you won't know how to do any of the problems from then. So make sure you got this down. Okay? All right, let's try another problem. Problem number 2. Right now, I'll rush through this one. You've got a 2,000 kilogram car. It has a momentum of 10,000 kilogram meters per second. How fast is it going? So what do we know? Well, one of our givens is 2,000 kilograms, and kilograms measures mass, so we know that's a mass. And it says it has a momentum. This is different from the one before. 10,000 kilogram meters per second. And how fast was it asking for? All right, velocity. All right, so here we go. If we look at our essential equation sheet, we'll see this equation here, but that won't really help us. What we need is this equation, but in the V flavor, which is just momentum divided by mass. So then we write down V equals P divided by M, and then we substitute. P is 10,000 kilogram meters per second, and it's divided by the mass, which is 2,000 kilograms. Okay, and remember, we do the numbers and the units separate. So P, the momentum, is 10,000 divided by 2,000. Check it out. We can actually cross out these zeros. What's 10 divided by 2? Oh yeah, that's 5. And guess what? The kilograms cancel out, and you're left with just meters per second for the units. And there you go. You know that this car, because of its momentum, is moving at 5 meters per second. Okay? So that's how you solve the basic momentum problems. Make sure you know how to do this again so that you can do it later on future things where we do more with momentum. It's a basic skill you got to know for the future. If you have any questions or conceptual misunderstandings, ask me in the beginning of class. I will see you then.